Hi, everyone. Welcome to this virtual conversation dedicated to the first step in implementing a digital inventory. My name is Katie Sinzi, and I am the managing editor at 3D Adapt Media. I have the honor to moderate this panel between Braid, Glass, and Alvaro that are here present. And we are going to talk about the digital inventory ecosystem and the main stakeholders that surround it. So most of you have probably already heard about the concept of digital inventory, a concept that is appealing for organizations which have a physical inventory and that do not always know exactly what their true costs are at the end of the year. And once combined with additive manufacturing, a digital inventory modus operandi seems a great alternative, as this combination may help address quantity requirements and understock parts issues. Today's virtual conversation aims to discuss the number of questions regarding the various stakeholders that come into play when implementing a digital inventory ecosystem, the main steps to implement one, the manufacturing countries, and even security and intellectual property issues surrounding this topic. And before we dive into our conversation, I would like to remind the audience that, as always, they can ask any questions in the Q&A chat in front of them, and then I will publish it for our panelists who are here present. And now I would like to give the floor to Alvaro so that he can introduce himself as well as the company he's working for.
Hello, everyone. My name is Álvaro Forero. I am working for Vivo Systems. We are a security company and started more than 30 years ago. And we are specialized in protection and monetization of software, hardware, and data. We are based in Germany, so our headquarters are in Karlsruhe, and we have subsidiaries around the world. My role in Vivo Systems, I am head of CERT. So my team, we are responsible for the management of the security incidents in our products. And I am also part of the security experts team in the company. And yeah, I've been working for Vivo Systems for the last 12 years.
Yeah, thank you, Alvaro. And yeah, I'm glad you're able to join our virtual panel today. What about you, Glass?
Yeah, so my name is Klaus Solberg. I'm working in DNV. DNV is a company working in certification, qualification, and basically anything related to risk. I'm working in the Department of Materials and Technology, where I'm dealing with the integrity of components and materials, and then specifically additively manufactured materials. So my background is from mechanical engineering. I recently finished my PhD with the topic fatigue design of additively manufactured components. Then I also started to get involved with the digital aspects of additive manufacturing.
All right, thank you, Glass. And last but not least, Braid, can you go ahead?
Thank you. My name is Braid Alarum. I work for Equinor, the largest energy company in Norway. I must say we used to be an oil and gas company, but we're now moving very fast into a more sustainable situation. And we now define ourselves as a broad energy company and also very dedicated to find more sustainable solutions from within the energy industry. I'm also I'm head of the Additive Manufacturing Center of Excellence in Equinor. I'm also chairman of the Field-Made Digital Inventory project, where we're developing a software platform for digital inventory. And I'm also chairman of the network called AM Energy. That's an international network for additive manufacturing.
Yeah, thank you, Braid. Just a quick note for my co-panelists. Please, when you're not speaking, maybe try to mute yourself so that we can, so that we do not have the echo when we listen to you, to the others. I mean, to the person who is speaking. So yeah, let's start straightforward. We usually talk about a transition towards digital inventory. Does that mean that the first condition to implement a digital warehouse should necessarily be to have an existing physical warehouse? And I'm starting with Braid.
Okay, the quick answer is no. Actually, you don't need an existing physical inventory to get the benefits of the new digital inventory. And I would spend a couple of seconds to explain why. And that is because the benefits are really manifold. It's not just reducing the physical inventory, of course, that's an important part of it. But what you can add to that is that you can also reduce lead time, which might end up being an even bigger benefit, both for the suppliers, but also for the end users, for the operators. And also reduction in lead time might lead to reduced production loss. If you're in a situation where you have a component failure and your production stops, of course, time is important. And if you can reduce the lead time by using the digital inventory, then of course you can reduce your production cost. But one area we haven't really discussed too much is the way we can use the whole ecosystem to create design improvement faster, using the opportunities within additive manufacturing, focusing on the opportunities within digital design, and using the whole ecosystem with the different roles that we have set up. Now, is it okay if I just show you a quick picture of how we see that the digital inventory ecosystem should look like? Is that okay?
Yes, Brad, that's perfectly fine. Please share us.
Just to show you how different the new ecosystem will look like compared to today. It's really a transformation using new technology. And as you can see here, we envision that you will have a digital ecosystem in the middle, and then you can purchase digital parts, digital design from anywhere in the world.
Okay.
It could be from Singapore or Silicon Valley or Italy, it could be anywhere.
Mm-hmm.
And then the idea is then you transport your digital parts through digital means, and you can produce the part locally
Okay.
wherever you need your parts. So then that means you can use additive manufacturing in your factories, and that means you can produce the parts locally.
All right.
And also you move to a production to order philosophy. So instead of keeping large inventories, you just keep them digitally and you produce a part when you need it, where you need it, according to this model here. And it really opens up a completely new flexibility. And the last benefit I haven't told about yet is the sustainability. You can reduce transport, you can reduce the amount of raw materials that you take out because you reduce the physical components in your physical inventories. And of course, we can come back to all the details, but the sustainability for me is a very important part of this new way of working.
All right. Thank you, Brad. So for those of you who haven't had the possibility to see the map that Brad just showed, it will probably come back to this map at the end of the conversation. So please be assured that Brad will ask, or I mean, will come back to this before the end of the panel. Class, what type of part should one analyze for a digital inventory?
I think when starting to looking for what should be used for digital inventories, I think we need to realize that we are actually in the beginning of this. And for example, aiming at extremely complex and critical parts might be difficult. So I think what we are looking at is aiming for parts with lower criticality, parts that have a kind of regular interval with replacements, so that it's easy to know when it's going to be replaced, or when, like, for example, wear parts that you can measure the wear and you can replace it when it's worn down. And it should also be parts that are easy to inspect, so that it's easy to have a good quality control and that we can build trust in having digital inventories. I think it's very easy to aim for to have an idea of these complex parts for additive manufacturing, but I don't necessarily think that's the main advantage here. I think
Okay.
here we want to reduce the lead time. We want to deliver parts on demand, and we want to have them with the right quality and the right material at the right time.
All
So then
right.
I think the less complex parts would be a very good place to start.
All right. Brian, I don't know if you would like to add something, because I know Equinor, can bring some parts as an energy company. Yeah.
Yes, I agree that it's a good idea to start with the more simpler parts. But through our efforts within digital inventories, we are using 2 greenfield projects as pilot projects. So one is the Johan Castberg field, and the other is the Johan Sverdrup phase 2. And of course, we have to look into not necessarily the complexity of the part, but the criticality. And if the criticality is high, then we need to replace it within 1 or 2 days. And of course, it's difficult to see that you can do on-demand production within 1 or 2 days. But with intermediate criticality, then you have to fix the problem within 45 days. And in that case, you can replace the philosophy from taking out of the physical inventory to actually on-demand production of the part. So yes, it's a good way to start, but in the work together with those 2 greenfield projects, we are looking into both critical and less critical parts, complex and less complex parts. But we find really important is to look into the total cost of ownership. So we shouldn't just look at isolated the cost of the production of the part, but looking into the total perspective. If you can improve the design, if you can extend the lifetime and so on, of course, then you can look into the original cost of the component with different eyes, and also the speed of how you can produce it is also important in that. The other area is that I would like to say that additive manufacturing has been really a catalyst for introducing the digital inventory. But as soon as you have the digital inventory, it's not the only technology that is possible to use for on-demand production. You can also look into CNC machining, which is equally applicable. But I've also read now that some companies, they also produce electronic circuits on demand. So I think really in the future, we can expand the idea of what kind of components we can produce on demand.
All right. So let's move a little bit from component to stakeholders brain. So in an additive manufacturing production process, I will focus now on AM as this is the main editorial focus of this feature panel. There are various software considerations to take into account, sometimes from various software publishers. There are also material considerations, as Class just mentioned, and even post-processing requirements to meet. So what are, according to you, all the various stakeholders who can be involved once a digital inventory system is implemented?
What we have done in this digital supply network model that we are working on within the digital inventory concept, we are really dividing the suppliers into different roles. And of course, this network is quite complex, and we have many different roles, and I can mention some of them. For instance, the IP owners, the original equipment manufacturers, they are very important here, and today they are dedicated to sell physical parts. But in the future, we believe that they should focus more on producing digital parts and sell digital designs rather than the physical, because the physical can be produced in dedicated factories. And that is, of course, the second type of suppliers. That is the on-demand factories that can produce parts fast with high reliability, repeatability, so that the whole concept of producing on demand actually works. In addition, you have engineering companies. Usually they work on our behalf. They are responsible for large projects, modifications, and constructions. Then, of course, they could be an important partner in this network. Then you have the verifiers, like a class here from DNV, it could be TIFF, could be Lloyd's, and so on. In many cases, we need a third-party evaluation to ensure that we have the right quality. We need to have certified factories and so on. Then we have the logistics providers. Even though we want to produce parts locally, still you need maybe some transport to the end user. For instance, in Norway, we have a lot of offshore installations. And actually, we are looking into transporting 3D printed parts with drones out to the platforms that we have in the North Sea. So that's really bringing the just-in-time philosophy really out there to the end user. So logistics is important, and of course the end user is very important here. Could be an energy company, but as soon as you have the whole network in operation, it could be equally applicable to any other industry. So it's really a universal concept. So the end user could be really anything. Could be in the defense industry, could be automotive, could be aerospace, could be anything.
All right. I will not focus only on one aspect, one consideration that you highlighted from the very beginning, and which is IP consideration. And I would like to ask Alvaro, our security expert, why he thinks IP can be a critical consideration here.
Yeah, so I like very much the way Britt was explaining the whole different stakeholders, because if we start with the producer or OEMs, if they start to moving from producing hardware or physical parts more to digital content, then if they sell one part, then how are they sure that no one will just copy this part and sell that to other people? So once you send the file the design leaves your company, then you lost the control. Yeah. So I really like this question, because many customers and people working with additive manufacturing, they came to us because they were not aware of the risks that are inherent of this new philosophy and new way that we start to see the world and the production. So if we start at the producers, there is this topic. The second is when you want to control how many parts get really produced. So you need a way to control that how many parts at the end when they get printed or produced were really printed, and not more than you intended, and then they will sell this in the black market.
Yeah, I see.
Then if we take the next stakeholder, for example, the engineering companies, maybe the designer, they give them a CAD file, and then they are doing all the conversion to geometry files, for example, STL files. And then they are doing all the engineering to figure out which are the best configuration for the material, which are the best part orientation, and part, how to put everything in the printing chamber. So there is also intellectual property in the process. So not only the design, but also the expertise of printing the parts.
Okay.
This is also that they develop during the time. So if at the end you can just extract or export configuration and someone just copy this, then they will lose also their intellectual property, because someone will learn from the process they took. They needed the time to get where we are there.
Okay.
And the next step would be the printers itself. So these are also OEMs, so they are producing printing machines. So they have an interest that the machines they are not copied, that they are not counterfeiting of the very good machines. So this also has intellectual properties of the software in the machines, which is very valuable, because they put a lot of effort and research efforts creating new software.
Yeah,
and then if they just get copied, then someone could just copy the machine one-to-one. So this is also what we see, not only in the additive manufacturing sector, in all other machine builders that are customers of Vibu systems, where we are helping to protect their machines also against counterfeiting.
Yeah.
So those are the main assets that we can talk about, and where the IP protection is distributed in the chain, the production chain.
Oh, but Alvaro, what could a complete intellectual property protection look like? I mean, IP protection landscape look like?
Yeah, so there are many challenges there because the first is you need to protect the design files for the next stakeholder. So you need to have a way to control who has access to this. So you need a way to assign first to protect files. So if we talk about protection, we talk about cryptography. So it means automatically we have some encryption keys, which means automatically you need to give someone these keys. And if you just copy the keys or everyone can copy the key, we end up on the first problem that we had. You just copy the file.
Correct.
So this is the first challenge, where to put the encryption keys. And for that, we are contributing in with our technology that we have secure elements, hardware elements, and software containers and cloud solutions to put and protect these encryption keys. And then we put on top this digital right management system. So because the next step is how to distribute these rights. If you start controlling who is able to get these keys, it means you need to control that somehow. And this is also part of the solution. So now you change from giving the people the control of who has permission to open these encrypted files.
Yeah. Yeah, I see. Um,
Maybe
and
one
then, yeah,
aspect I forgot, or no, I would like to mention
yeah,
now. So maybe I will mention that later, but I think it's a good point now. A good moment is
yeah.
that to control how many parts get produced at the end, which I said before is also an issue, a security issue. For that, you would need to have a sort of security, safe counter that cannot be manipulated. And for that, you need to put this like on a kind of prepaid card or some hardware element that cannot be just easily manipulated. And so we are also working here directly with printer manufacturers. So they put in their firmware the possibility to count and to decrement these safe counters.
That's very interesting. I like that idea of prepaid system or prepaid card, as you just highlighted. But if we focus on manufacturing itself, can we say that part consistency is always met in a digital inventory system process? How do we ensure that, class?
Yes, I think we can if we go through a qualification process first.
Yeah.
So from DNV, we have a recommended practice for metal additive manufacturing, where we divide parts into criticality levels. So we have different additive manufacturing categories: 1, 2, 3, and then 1 is parts of low criticality, and 3 is parts of high criticality.
Okay.
And then we have defined it so that all parts need to have a qualified build process. That means you have to define a set of parameters. You need to print some specimens, tensile test, microstructure, hardness, porosity, distributed within the chamber, and perform those tests and have a controlled atmosphere. And then you have kind of a controlled process, which is qualified. Then if you're going for higher critical parts, additive manufacturing 2, category 2 or 3, then you're going to need production testing on the print file when you print the part. So at first you qualify the process, and then you print some specimens, test specimens on the side of your part to test the consistency of the material quality.
Okay.
And then on the most critical parts, also destructive testing of the part is needed to check the process.
Okay.
So following that regime, we believe that we can ensure part consistency. And yeah.
Correct me if I'm wrong, because when you were talking, you were also a little bit exploring that process of qualification. So is part consistency directly linked to qualification of each item throughout the additive manufacturing value chain?
Yes, I believe that's why you're doing the qualification to ensure part consistency and material property consistency.
Okay. All right.
But speaking of of uh, of qualification, we also have this readiness level concept. So you can have parts in a digital inventory that are not that have a lower readiness level. So that means that you need to qualify something after it's ordered, or you can pre-qualify it and have it ready for order, kind of. So that depends on how you want to structure your business model. And do you want to pre-qualify everything and have it delivered fast, or do you want to have longer time for delivery and then do the testing? So there are different methods of different ways of doing this, we believe.
All right. I don't know if Bright wants to add something.
Yes, I would like to add something. This is really critical for this ecosystem to function, because we need to be quite sure that if you produce a part in northern Norway or in Italy or in Germany or in Brazil or anywhere in the world, you get the same result.
Yeah.
So the repeatability is really critical. And I know that 3D printing is not plug and play yet. We know that we get different results with local conditions. So we really need to ensure that the qualification work and certification work is done so that we know that the result would be the same anywhere.
All right. Thank you, Braid. So is it possible to have measurable results? I mean, like a percentage that enable companies to know what they save when they reduce the physical inventory by adopting AM, or when they move towards a digital inventory modus operandi?
Yes, I'll just continue then, Katie.
Yeah.
This is truly a transformation. And in some areas, it's rather easy to measure the success, but maybe not in all areas. But I strongly believe that we are talking about some sort of Kodak moment here.
Yeah.
And if you are in this transformation and you succeed there, then you will see new business opportunities. And if you stick to the old, then you might see a reduction in your possibilities in the market. So that's really something we have to bear in mind. And that is measurable. But it's important to see that the cost reduction that we expect will be throughout the network, not just for the producer, not just for the end user, but for everyone. And as I mentioned earlier, the total cost of ownership is a very important term to be able to show the total cost savings throughout. And for instance, by instead of having a linear supply chain that we are used to with many stepping stones on the way, with many possibilities of delays, you have controls, you have administration, you have costs, and even sometimes lack of trust. Then, of course, moving to a network-based supply model, then we expect that it will be much faster, less administration. We can easily implement smart contracts so that you reduce the administration and so on. And that cost benefit will benefit, of course, everyone in this network model. So the reduction in inventory is, of course, very highly relevant for the end user, but also for all the different suppliers, because they can reduce the inventory levels as well. And then how can we measure the implications of reduced lead time? That will really help us improving production and progress in projects and so on. So in some cases, we know that there's a benefit, but it might be hard to measure. And the last area is, with this new model, you can improve your design much faster than in the old model. And what is the value of a fast improved design? That is also really interesting and important to see in the future how this
Yeah.
will really work out.
Oh, thank you. Yeah, that's yeah, Alvaro, you're muted.
Yes, maybe I would like to add. I was thinking, what could I add to this very good question, but I think you covered a lot. So I think I will just add that the part of counting the produced parts is what I meant before. That, for example, if you want to know how many parts were produced, if they buy the parts or the rights to print 1,000 parts from the digital design, for example, then you maybe will like to know if there is a feedback. They really produce these 1,000 parts they bought, or they produced only 500. So if you have these counters which are secure, you can also get information like reporting systems, how many parts were already produced. So this is also, some of our customers are interested on this and communicated to us this that they would like to know this information for their reports and analysis.
All right. Oh, Alvaro, do you have any landscape that may enable us to better visualize this IP protection landscape?
Um, Let me
Yeah.
see.
While Alvaro is checking, I would like to remind the audience that they can still ask their questions right now, as this is the right time for the panelists to answer any questions you may have regarding this topic.
I think I can share one slide we were
All right.
using from let me see.
Yeah.
So I will select, okay, all to share very quickly. So now you should see that it's loading. So now you should see it.
Yeah.
So let me jump to this slide. So
Yeah.
we did a presentation on the German-Japanese additive manufacturing camp
Mm-hmm.
like 1 month ago.
Mm-hmm.
And so here we were explaining from our perspective and how we could contribute to protect this. So we were talking before about the stakeholders. So you see here the producer, designer. So if you need to protect the 3D file, or if you need to do some pre-processing, and then you will have a print job that you would like also to protect, and then you have the printer. And this is what I meant, that from a digital right management system, which is this circle here, you will distribute the rights. So this software can use the encryption keys to decrypt the 3D file, and the printer will also get keys to decrypt the printing job, and we'll also get the counters. And you can have here like a hardware device or software files, like encrypted files, to protect that counters. And so what we see here is that you need, as I was mentioning before, if you start using encryption keys, and you will have on the top the challenge of how to manage all these. For example, if you talk about uh, something very simple, email encryption, then the technology for an email encryption is there. The problem is usually the management of the digital certificates, and some people use PGP, other people use SMIME certificates, and maybe you have and some people working with one or people working with another. So you now have to provide this security, you need some additional challenges, like how to distribute and manage the access to the encryption keys, and for how long. Maybe you want to give access only for amount of period and not for always, maybe only 1 month, and so on. So all of this can be integrated using, at the left, can be connected to an ERP or CRM system or e-commerce systems. So everything works automatically, and no one needs to log in on somewhere and give manually any rights.
All right. Yeah.
Yeah,
Thank you. Thank you,
I
Alvaro.
hope that helps. I think showing a diagram is easier than explaining all of this. Yeah,
Yeah,
like maybe.
that's right. Yeah, it's well explained with that visual. And great. Before I move to my next question, could you just please show the audience again that map that you just showed at the beginning, because I've read that some people in the audience did not have the opportunity to see it very clearly.
Okay, you see it?
It's loading. Yeah, we can see it. All right. So yeah, so that's the digital ecosystem you were talking about, with the possibility to produce the part anywhere in the world and to get it locally. Is that correct?
Yeah, that's correct. And that's really opening up for many different benefits
Yeah.
that we've been into, but that's something we haven't discussed too much. I mentioned the sustainability part,
Mm-hmm.
and of course, the digital inventory is perfectly fit for a circular economy model together with additive manufacturing. First of all, you can reduce the amount of raw material that you use, both in the process itself by building from nothing to the component you need, but also by reducing physical components that you actually have to purchase. Then you also reduce outtake of new raw material. And if you do that, you also reduce CO2 emissions related to extracting raw materials. In this model, you can reduce transport. As you see, you can transport it digitally. Within operations and maintenance, you can reduce the physical inventory. You can extend lifetime by using additive manufacturing techniques to repair components, for instance, and you can also improve function. So therefore, you can increase the efficiency of rotating equipment. Your turbines could be any piece of equipment, and by increasing efficiency, you can reduce fuel consumption and therefore reduce the CO2 emissions and even the NOx emissions. And the last area that we see now is that there is a possibility of going from scrap metal directly into 3D printing powder. There actually is a company from Italy called Fenice. They have a technology to do this. And therefore, we can close the circuit and use recycled metal powder as a feedstock locally when we produce the parts we need. So it's really interesting how this actually fits into a circular model. And this actually then again leads to a higher resilience when it comes to getting the parts that you need, because you have no borders to cross, you have no factories in countries far away, so you have control of everything locally, and then you have no borders that can close, and you have, as I said, you can even get the feedstock locally by recycling scrap metal. So that means also for us, this new model means a higher resilience when it comes to getting the parts we need.
Thank you, Brad. At present, should we fear the termination of certain jobs with digital inventory or a significant skills gap? Alvaro?
Yeah, so I believe this is a transformation. It's a very big step. So we will need that if we don't want to be afraid of losing jobs, so the current needed in the production, I think it needs to start in very early stages. For example, from the school, that the kids already have some possibilities to learn about new technologies, and then of course later at universities or other places, at a professional level, we need to prepare people to the new paradigms of the in the world, the new technologies. So I think this is a big transformation, and we need to get prepared for it, to have the people, the skilled people.
Yeah, thank you, Alvaro. And before I move to the last question, I would like to ask if regarding quality assurance and qualification and certification, what is the next challenge to address with regard to this respective field, to this topic? Sorry.
Yeah, I think that's a very interesting question. I think in terms of material quality and part quality, that's something we have quite good control on. There has been done a lot of research defining all these materials, and we have methods of testing. And I really think the next challenge is, for example, the creating the trust between the OEMs, the manufacturers, the end users. How can we actually show that yes, the same part is printed in another country? Yes, an OEM can trust the manufacturer. All of these steps. If yeah, I think that's the main challenge, because in terms of material quality, I think that's of course there are some issues there, but I think they are easy to solve when you have the right tools and the right methods.
Yeah, correct.
But really getting all the parties on board, and having, for example, OEMs see that yes, we can make money in different countries. We don't have to be located close to the manufacturer to trust that he is producing of high quality.
Yeah.
I think that is, and I think in addition to that, I think monitoring with additive manufacturing, we have a lot more monitoring possibilities than we did before. So that means that you don't have to send a person to a manufacturer to stand and look at the machine if it's printing correctly. You can use the monitoring data to qualify that, yes, we see that these data are consistent. We see that what you're producing is giving consistent results, and we can qualify the part.
All right.
So I think also that is one of the challenges to the digital qualification machines.
All right. It looks like we have no questions from the audience. So I would like to ask Braid. Yeah, Alvaro.
I saw once. I saw somewhere someone wrote regarding the security.
Yeah.
Yes. Or do you want to talk about later, or it's now good to answer?
Actually, I read, but it looks like it was a message directed to you. So Roloff is
okay.
yes.
So
Maybe
but
Roloff,
it's
if you can still hear us, if you have any
it's a
point.
good point.
Yeah.
Okay. Yeah, so the question was if, or he wrote that there is the Secure Distributed Additive Manufacturing, SDAM Alliance, and they are looking after security in the AM supply chain.
So
Exactly. And we know that because some of our customers are on this alliance. And we have also customers which are not part of this alliance. So some customers, they need a fast solution. They need already to start with something. So there we can help until we have more like standard solutions than when other companies start seeing that there is a standard solution, there are standard solutions out there, they maybe start to join and also implement the standard in their machines and so forth. Yeah.
All right.
But thanks for the contribution, Roloff.
All right, thank you, Alvaro. So, any before Brett share his concluding thoughts, class, Alvaro, do you have any questions that you would like to ask your co-panelist?
Good question.
Yes, good question. I think we have covered a lot of interesting topics today, and I think it's a lot of things that needs to be discussed. But I think we have actually touched upon the key elements here.
All right.
Don't necessarily have a question.
Yeah, Brett, you have the
floor. I would like to ask Alvaro a question. You mentioned also the way to safeguard the IP rights. We can use, of course, many different technologies, but in the field med digital inventory that I'm chairman for, we are using blockchain technology to use that for track and trace, and also to safeguard that the ownership for the digital content is actually locked, so that it's difficult to steal or to tamper with the design, and so that you can also ensure that you actually own your own design. So have you considered using blockchain as well?
So I'm leading two different projects, one research project and one customer project, and not in this project, but I know that other colleagues are working in this topic. Yes. But maybe what we need to differentiate here is that one is if you are able to manipulate something, and the other problem is if you can access something. So if something, as I said at the beginning, if something is digital and you receive the file, yes, you don't have the control. If you have the digital design, or if you have the build job and you have the machine, then you can just produce all what you want. So yeah, so I think that part would solve the authenticity part with yeah, but not the confidentiality part. So for that we need and the secure counting. I said before that we would need to also have a way to control that directly in the printers.
Yeah. Um, Alvaro, there is a remark from Mark, not really a question, but Mark is saying that he actually addressed this IP issue yesterday, and how it will play out is still an issue in a less qualified way he might add. So that's not really a question, more of a point. And so he said no machine, no factory justified, and subsequent print. So it looks like maybe people do not have the right skills to address these IP issue. Do manufacturers require some specific training, some regarding the security and IP program?
Yes, in the middle you have the pre-processing part. So maybe the engineering part, as I mentioned before, is not just taking the STL file, the design file, and send it to the printer. You have pre-processing know-how, and you need to learn how what is the best orientation, or if you're doing your nesting, you are doing the support for the parts. So there are some companies and universities also working on software to do this more automatically, and there are many software providers today already doing a lot automatically. But we know from research projects that there is also a lot of research on that field to do more and more automation, but there are still like know-how either in the software or today in the people doing that. Yes, the people using the software by hand and doing a combination by hand, and what the software automatically offers the options. Maybe you click on the nesting option in the software, but maybe that's not the best for the production, because maybe depending on the position, if you are in the middle or somewhere else, we will have some differences. So there is, from what we know from the projects, but most from research projects, because they are addressing these big open questions. I know that there is also intellectual property in these engineering parts in the middle, the pre-processing, and if we do more and more software to automate, it means now the intellectual property is in this software. So if you have in the graphic of Breed this like some kind of cloud service that you just connect and order the files. If you also have pre-processing, or you have something on this cloud solution, then you also would need to protect this because this is your intellectual property as software running there. So that's why I wanted to stress out, it's not just the design, it's also the processing know-how, and maybe the material configuration as well. Also a relevant topic,
Yeah.
and the software that you are using to do the pre-processing and on the machines.
All right. Yeah. Thank you, Alvaro. Brett, any last comments regarding the next challenge to address in your respective field of activity regarding this topic?
Yes, I tend to get that question from suppliers that we have a dialogue with. Should I just go out and buy a metal 3D printer? And I said, that is the last thing you should do. First, you have to build competence. That's really step number one. And in a way, that's doesn't require a lot of capex money to invest in equipment. But build competence and understand the opportunities, and also the problems with or issues with 3D printing. It's not just plug and play all the time. That is really important. And the other area is that the old business models that we are using, the contracts models and the incentives that we have in our contracts, they might not work anymore in this new way of working. Let's see what happened in the music industry, from producing CDs to actually being fully digital. And in a way, we are going through the same mechanisms. And how are we going to ensure that all the suppliers earn money within the digital space compared to selling physical components? That's really something we need to look into together. How can we ensure good new business models? And the other areas I think is important is that being connected, we will see new collaborative models and also a closer relationship between the end user and the supplier. And that can also give us some very positive effects in that we can design better equipment faster. So we really can't see the full picture of where we will end up, because it's so different from where we are now. So we can just really start the journey and look forward to a transformation that can really do things in a completely new and better way.
Thank you, Brad. Any last words from you, Alvaro?
I would like to add to this transformation that yes, many customers from us, they said they were years ago more like a hardware company. They were selling different machines, with different capabilities. So they had a lot of logistics costs and had to distribute these machines. And now they are moving to converting more a software company. So the hardware is the same, and they are enabling features on demand. So this is also an interesting point in all this, that they also to reduce all the logistic, and you have the same hardware, and depending on what the people buy, they get the rights to use more or less features. So this is also yes, new kind of sell products for some OEMs that they were used just to sell hardware.
All right. Thank you, Alvaro. Oh, well, that's it. Thank you for joining us, gentlemen, for this virtual panel dedicated to digital inventory and what to do to implement it within an additive manufacturing production environment. Thank you to the audience for joining us. Thank you for your contributions. Um, I will now close the panel, and I would like to wish you a very great end of day, and stay safe and stay tuned to the next virtual panel dedicated to one vertical industries within the additive manufacturing industry. So stay safe and stay tuned wherever you are in the world.
Okay.
Bye.
Thank you.
you.
Bye.
Thank
Thanks for
you.
the
Bye.
invitation.
Bye.
Bye bye.
Bye.